Okay, this is Algebra 2, graphing reciprocal functions, page 483, it's section 740. If we look at a reciprocal function, reciprocal, do you know what reciprocal is?
The opposite, or the flipped upside down.
Okay. It's
Inverted.
Yeah, inverted, right? So if the reciprocal of 4 is 1/4, the reciprocal of 1/5 is 5, right? So a reciprocal function, the ones that we're going to start out with look like this. Okay? And they actually have a name. Okay? We call them a hyperbola. All right? Not a parabola, but a hyperbola. Okay? So if we take a look at this particular function, I'm going to do a t-table to show you. And this is x and this is y. You'll notice that I cannot use 0 because it's in the denominator. So I can use let's just start with the -3. So if I have a -3, I have a -1/3 is y. If I have a -2, I have a -1/2 is y. If I have a -1, I have a -1. If I cannot use 0, it's undefined. Okay, because it makes that function is undefined. So I put in 1, I get 1 back. If I put in 2, I get 1/2. If I put in 3, I get 1/9. Excuse me, 1/3, right?
Yeah.
Okay. And so on. Okay. Now the interesting thing is, well, I'll leave it like that for right now. Okay. So I'm not sure if this is pointing on the graph, but we'll move it over a little bit so we can see this. Let's take a look at this. I'm just going to graph, here's a -3, and then I have a -1/3, correct?
Yes.
And then I have a -2, a -1/2, I have a -1, -1, right? What would happen if I put like a -1/2 in here? Watch this. This is kind of weird. I'll put 1 over a -1/2. And we did complex fractions, right? That would be 1 divided by a -1/2, which is 1 times a -2, which is a -2. So here's the interesting thing. If I put -1/2 in, I get a -2. So what's happening, Joey, is it's following this down like this. You see that?
Yeah.
Now, we skipped this, we jumped, right? Take a look at the 1. If we have 1, 1, 2, 1/2, 3 is 1/3. And if I put in these values, if I put in 1/2, I get 2. And as I get closer, it follows this just like that. And this is a hyperbola. And what we have created is this word that we call an asymptote. asymptote. Remember, this is a boundary in which a graph gets closer to but never touches. So what's happening, Joey, is that it's getting closer to this, but never touching it. On here and here. And over here it's getting closer to the x-axis, here and here, but never touching it. You see that?
Yeah.
Okay. So, when we talk about domain, right, which we're going to talk about, domain. The domain, remember, is the x values. Remember?
Yeah.
So we go all the way to -infinity, and we go to 0. We don't touch 0. So what's happening is the domain is from a -infinity to 0, and then it unions. Then we jump this, and we go from 0 to infinity. Does that make sense?
Yeah.
And the range, okay, the range And I'm gonna go back to the asymptote in just a minute, but I'm talking about the range here. We're going from down here, and this arrow goes down, doesn't it? So we go from a negative infinity to here, once again to 0. So it's the same thing. And then we jump it, and then we go to infinity. Now here's the kicker. We have two lines that we get closer to but we never touch. This one and this one. Okay? This one is y equals 0. Y equals 0 is an asymptote. Your book might have it as f of x equals 0. Remember, f of x is a fancy way of writing it. We also have x equals 0 as an asymptote. Okay? Now, I want to share with you that the way that we get the vertical one, this right here, this is a vertical asymptote, is that our denominator cannot be 0. The horizontal comes from something totally different. But the vertical one comes from the denominator. Okay? So let's take a look at, on page 483, example 1. It says, determine the value for which f of x equals 3 over 2x plus 5 is not defined. So we want to find the values that are not defined. Let's take a look at number 1. F of x equals 3 over 2x plus 5. This is a hyperbola, Joey. We're not supposed to graph it. It says just find the values that aren't defined. Well, we want to find all the values that make the denominator 0. So we take 2x plus 5 and we set it equal to 0. So this is kind of weird, Joey. We want to find all the values that don't equal 0 by setting it equal to 0. So we move the 5 over, right? And then we divide by 2. So x equals 5 halves. So therefore, x cannot equal negative 5 halves. Now what I want to do is write it in interval notation for you, because this is going to be our domain. And so you have to learn to write it in interval notation. So we're going to go from a negative infinity to a negative 5 halves. Okay? And we're going to union a negative 5 halves to infinity. So that means that right there says everything but a negative 5 halves. Everything but a negative 5 halves. Okay. All right, would you do this one, Joey? Number 2. F of x equals 7 over 3x plus 2. Would you do that? So we're going to set 3x plus 2 equal to 0. Solve. Divide by 3. X equals negative 2/3. So we're going to go from a negative infinity to negative 2/3 union, negative 2/3 to infinity. Now I'm going to warn you, Joey, in the book they don't use this notation, but I want you to get used to it. Okay? So let's turn the page, Joey, to the next page. And it says example 2, which is going to be our example 3. It says identify the asymptote, the domain, and range of each function. Okay, you can see the graph there, right?
Mm-hmm.
Okay, let's take a look at the graph. Identify, this is 3, it's actually A. So we're going to identify the asymptote, the asymptotes. There are 2, Joey. Let's take a look at the vertical asymptote first. Now, Joey, the vertical asymptote can be found either by the graph And I can graph this one real quick, Joey. This is what it looks like.
You don't have to.
Okay. It goes like this and like this, doesn't it?
Yeah.
Okay. All right, well, Joey, hopefully they can see that graph. I told you that it's y equals 2 over x minus 3, is that right?
Yes.
Okay, well, one asymptote is this guy right here, the vertical one, and it's just x, so one asymptote. And now here's the thing, when we do an asymptote, when they ask for an asymptote, it's a line. So this is a vertical line, this is our vertical line, Joey. Okay? Not this, okay? This is what it can equal, but this is a line. So one asymptote is this. An asymptote is a line. Remember, it's a line. The boundary which a graph gets close to, it never touches. So maybe I should put that here so you understand fully that it's a line. Okay? Now there's also this one. That's a horizontal line, Joey. So a horizontal line begins y equals. And what's the value of that? 0. I think you were going to say it, right? Okay. It is 0, horizontal.
So x is vertical and y is.
Exactly. X is a vertical line, y is horizontal. All right,
It's
so
kind of different.
that is kind of different. I know, it's opposite. It seems to be opposite, right? Okay, Joey. I don't know if you remember that from Algebra 1, but then it says find the domain. Well, the domain is all numbers except that, right?
Yes.
This is the domain. So all numbers except that goes from a negative infinity to 3 union 3 to infinity.
And then the same with 0.
Well, the same is the other one, except for if we use this one. Okay, so this is range. So this is domain, and this is range. So we go from negative infinity to 0, union.
0 to 2.
There you go. Okay. Now, one thing we can do is, this is, remember, this is a parent graph, so we can move it around. Okay, now what we're going to do is, we're not going to use one number, but on page 485, there's a chart there that talks about moving stuff around. Okay, and I'm going to write it like this: f of x equals a over b times x minus b. No, it's x minus h, isn't it?
Yeah.
And then plus k, right?
Yeah.
I'm going to, b makes it fatter
Yeah.
or skinny, okay? We're not going to use b a lot in this. We will in other graphs, but not in this one, okay? This right here is a vertical translation.
Moves it up and down.
Right. It's a vertical translation. Okay? This right here is a horizontal translation. Now, Joey, you'll remember that the horizontal translation is always backwards because this is a subtraction sign. You see what I'm saying?
Yeah.
So if we do this, I'm going to give you an example. Let's say that we do this. Number 4. If we do f of x equals negative 3 over x plus 1 minus 4. Okay, let's talk about that. Okay, if we talk about this one, Joey, this is moved
Down 4 and
it's moved left 1 and down 4. Okay. All right, so the whole thing is moved down. All right. So take a look on this is example 3B on page 485. Tell me where the asymptotes are.
on 3B.
3B.
it would be x is equal to a -4.
-4. So, hopefully they can still see this. All right, so Joey, one of the asymptotes is at a -4, okay? And I should have been putting these on as dotted lines all along. I kind of forgot.
And
What?
y,
And then where's the other one? And where does that come from, Joey? In this problem, where does that come from?
it comes from
It is moved down 4.
yeah.
Okay, all right. Now, what else is an asymptote?
Y equals -1.
-1, right? And that's a vertical, and that comes from right here.
From
-1, right? That comes from right here, so we're right here. Right, Joseph?
Yes.
All right, now, Joe, we normally graphed here and here, didn't we, these two?
Yeah.
Remember all our other graphs? But now they're here and here. Why?
It's because the numerator is negative.
It's what?
The numerator is negative.
That's exactly right. It flips it. It goes from here to here, if it's negative. If it's positive, it goes from here to here. Okay, so it looks like, and I'm just gonna do this very quickly. Now, you can use a t-table, right?
Yes.
When I use a t-table, I might put a -2 in. Cause see, a -2 is this area,
Yeah.
right? Okay.
Yeah.
So I'm just gonna do a little t-table. I might have to put it over here so I got some more room. I'm hoping that this can see that.
You move that desk. You move that.
Nope, I think we're good. Okay, so I'm gonna put in, I said a -2, right?
Yes.
So if I put a -2 in, I get a -3. This is a -2 plus 1. A -2 plus 1 is a -1 minus 4. So this is a +3 plus a -4, which is a -1. So if I put in a -2, Joe, if I put in a -2, all right, I get a -1. Okay, so let's put in a -3, Joe. Put it in a -3, I get a -3. I take a -3 plus 1 is -2 minus 4. So this is 1 1/2, 1.5 plus -1, which is 1/2, isn't it? Okay, so at a -3, Joey, which is right here, I get this. I get what? That isn't right, is it? Did I do that right? Oh, yeah. It's gotta go like this, right?
Yes.
Okay, so this point is wrong. What did I do wrong here? A -3,
Should be -2 or -1. Yeah. Should be right.
so -3, it's a +1/2.
Should be.
Oh, this is a -4. Remember?
Oh.
It's a -4.
Oh.
So a -4 minus 1 1/2 is what? 2.5? Is that right?
Yes. Should be. Should be.
Yeah.
Yeah.
Let's see if this works. So a -3, Joey, it's a -3, 1, 2.5. So it actually comes,
Should be. Should it be a -2.5?
yes. There we go. I just erased that out there, Joey. So a -2, what was it? -2 what?
-3, -2.5, -2, -1.
There we go. So there we go, Joey.
That's
And then I can just flip-flop these points over here. So it'll come the same as when it's 1 over, it'll be down here, right? So it goes like this, like that.
yeah.
See how that works?
Mhm.
Okay, all right, my bad, I kinda got. All right, so what I'm going to do is have you do a few of these. We are going to stay away from B, having a B there,
Okay.
which will work to your benefit, but it's not necessary right now. So your assignment is page 47, numbers 7 through 10 all common, 12 through 18 even. I'll get you some graph paper, because it says graph each function, state the domain and range, okay? Now, we graphed that, did we state the domain and range?
We didn't on that one, no.
Okay, but we have before, do you kinda understand?
Yeah.
The domain on this one would be from negative infinity
It'd be
to a
negative,
-1,
-1 and then,
jump it,
yeah,
and then this one would be from negative infinity to -4 and then jump it.
yeah.
Okay, alright, there you go. This is due Friday, I believe.
Whenever I'm back.
Yes. But for the other ones, it'll be due Friday.